And we're going to start. We had just finished our lab yesterday. Okay, we finished our lab on blocking dogs. So, what was one of the main things that we learned about in our packet what did blocking do for us? Okay, what did blocking do for us? Okay, remember when we blocked, what did it do with the data? It made it more squished together. Okay, good. When we blocked the data, when we blocked by breed, it made the data more squished together. Okay, it made it more consistent. It made it less varied. Okay, do you remember that? So blocking helped us. So here is what we got going on here. When the objective is to compare two or more populations, and you want to decrease the variability within the samples. Okay, that's what we did. Yeah, so it's nice and compact together, just like it was on our dog breeding, our dog lab yesterday. So what we are going to do first is block like items together. When we blocked by breed, I had y'all move around the room, and what did you do? You blocked. There was what kind of groups were there? An Akita. There was an Akita group. There was a Collie group. Beagle and Dalmatians. Good. So we had a group for each. We went ahead and we glumped like items together. What does that sound like when we make homogeneous groups and make them connect? We put them together. Yes. So blocking in experiments is similar to stratifying. In fact, if we made a little analogy, you could say this. Stratifying is we did that when we took sampling, as blocking is the same thing when we do experiments. And so what happened was these just developed separately in different parts of the world or at different times. And so they got called different things. Okay, they got called stratifying when people took samples, and they got called blocking when you were doing an experiment. But they are the same thing where you group homogeneous groups. You make homogeneous groups to reduce variation. Okay, so blocking will allow us to make a more precise overall conclusion. Do you remember when we blocked by breed? Weren't we able to tell the difference in the treatments? Let me get that picture pulled up. Blocking by breed, if we look back at what page that was on, here, page 19. Remember how we had nice compact data? And we were able to tell the difference in the treatments. We could tell that exercise and calcium was the best, was clearly the best. So blocking, now we blocked here on the next page by clinic. Why did this one not do as good of a job with blocking? Why did this not do as good of a job? Good. These treatments results overlap, so you can't tell which one is better. But why was blocking by clinic not the better choice than blocking by breed? What was going on? Breed, okay, look, very good. Breed, do you remember here from negative 71, look, from negative 71 to negative 144, breed had a lot more variability in it, so when we took that out, it condensed all the data together. Clinic, did it have very much variability in it? It just went from like negative 98 to, I mean, look, it just moved a little. So we didn't have as much variability. So we didn't take away as much, and so it didn't make it look quite as nice. All right, so back to here. So one of the keys is that we're going to block to control the effects. Here we go. We're going to block to control the effects of some extraneous variables, such as smoking, cholesterol. Maybe you have those that smoke and those that don't smoke. And if you think smoking is going to affect your lung capacity, then you don't want to compare smokers to non-smokers. Okay? Oh, that. Okay. All right. So I actually have a couple of songs to help us with some of this stuff that we're going to, I think we have actually several songs today. So I'm going to go ahead and pull those up. The first one, oh, we've already done the principles of experimental design, right? Did we do this? Oh, Well, there you go. We're going to do that one first. Okay? So we have the song for Principles of Experimental Design, and then we have one for blocking. So let me pull that up with the notes. So here we go. We saw our little songs. We know that blocking reduces variation. So now let's move on. We're going to go ahead and show you, we're going to talk about how to draw our diagram when you block. So here we go. Over a 4-month period, among 30 people with bipolar disorder, patients who were given a high dose of omega-3 fats and fish oils improved significantly more than those given a placebo. Their bipolar symptoms were reduced. Now, I think we've done this story before, but we just did it with a basic, completely randomized picture. But suppose some of these 30 subjects are very active people who walk a lot or get very vigorous exercise several times a week, while others tended to be more sedentary and work office jobs and watch a lot of TV. So consider tackling the confounding variable of exercise. And so we want to design an experiment to control that issue. Because what are we measuring here? First of all, what is the thing that we are measuring in this problem? Our response. Okay, good. We are measuring the response. What's the explanatory variable? What are we testing here? Okay, that's what we measure. That's what the response we are checking. Reduction of bipolar symptoms. Okay, and what is it that they're doing to perhaps do that? What are we testing to see? What? We don't want to test exercise. We want to test to see if this high dose of omega-3 fats will do it. So there's a particular medicine that we are testing. But the problem is that some exercise and some don't, and that is a confounding variable. So we don't want to test exercise. We want to test the medicine. So I need to control. Okay, so remember, you make an experiment. What do you do? Control, randomize, repeat. So the first part is controlling, and blocking can control confounding variables. So therefore, control, randomize, repeat. We will block first. So that's what we're going to do first. We are going to start our little design with our 30 bipolar patients. And we will block first. So I do my little ditty where I break out. And instead of writing randomly assign, I first block. So I'm writing block. You block into a trait. And I need to make a little song for this. You block into a trait and you randomly assign into a treatment. You block into a trait. And what is the trait that we are controlling? What are we trying to control? Good. Those that exercise and those that do not exercise. So we block into a trait to control it. All right? Now, do you know how many of those 30? Do you know that this is 15 and 15? No, you do not. So you cannot put a number there. Okay? You do not know it's 15 and 15. Now, one last thing before we go on. Do you remember how when we would write randomly assign, we have to tell how we did that? By putting in a bag, shaking well, and so on and so forth? Well, we have to tell two things about blocking. We have to tell how we will block and why we will block. So that's what we're going to do first. How are we blocking? Perfect. I will block by exercise or activity level. That'd be a good one. I block by activity level because why? Okay, it does reduce variability, yes, But what we have to reference when we say why, the reason we block is because that can affect the response. Remember, I see you have a trait there that may affect the way subjects respond. So it may, because exercise may affect, and what are we measuring? Okay, good. So I'm going to put exercise may affect bipolar symptoms. Okay, so I see you have a trait there, and that's exercise, that may affect the way subjects respond to what we are measuring, which is bipolar symptoms. Okay, so that's what you have to write whenever you block. Now I have 2 blocks. So I'm going to go and do an exercise experiment, and I'm going to go and do a no exercise experiment. Am I ever going to compare exercisers to no exercisers? No, you're just going to do exercisers. And so in fact, we're going to not even have to write anything for the no exercise. We're going to put repeat the experiment within this block. So I'm only going to draw it once. Repeat the experiment that I'm about to draw up above within this block. Is that okay if I write that instead of drawing all of it again? Okay. So we have within each block is an experiment. Okay. So now I got exercise. From here on out, it's like what you have done. What do I do to get into the treatment groups? Good. Randomly assign. So random assignment. And randomly assign to the treatment groups omega-3 fish oil or placebo. Good. Do I know how many are going into each one of those groups? No, it will be half of the exercisers. So that's what I'm going to explain here. So here I have random assignment. So what do I put? I say, good. Let me do this in a different color so that you can see it clearly. Put, good. Put all exercisers in a bag. Shake well. Pull out half for omega-3 and half for placebo. All right. We're rocking and rolling. This thing's going to be done here in just a second. Okay, so after the patients take their medicine, then what do? Now we got to measure what the heck that medicine did for them. So we are going to measure, and what are we measuring in this problem? Good, reduction of bipolar symptoms. And I'm just going to put ditto for that one there so I don't have to write it again. I like that. Ditto marks. And finally, we come together, and what are we comparing here? Compare the, how do you think they're measuring this? Do you think they're going, yes or no, you improved? Oh, you think on a scale? Okay, they did a scale of improvement. Okay, so measure average level of improvement. You know what? And I think I've been leaving this part off that needs to be there to see which treatment does what? Works best, I guess you could say. We'll just say works best. I mean, really I should say, but I'm getting tired of writing. Really I should say reduces the bipolar symptoms the best. Okay? When I say works best, I mean reduces bipolar symptoms the best. Okay, and then we repeated it up there. We're done. So this is a blocking experiment. Lots of stuff in there, right? Okay, so we need to practice that. So I want you to skip number 2, and let's go over to number 3. Okay, so for number 3, we're going to read this, and I do have one thing I'm going to have you cross out, so follow along as we read this so that you can cross out something when we get to it. You are participating in the design of a medical experiment to investigate whether a new dietary supplement will reduce cholesterol level of middle-aged men. 60 randomly selected men are available for the study. It is known from past studies that smoking and weight can affect cholesterol levels in men. I would like for you to mark off and weight. We're just going to consider that smoking is a confounding variable. Okay, so we know from past studies that smoking can actually affect your cholesterol levels in men. So we want to describe the design of an appropriate experiment. Is blocking necessary in this case? Explain. Um, what's our explanatory variable? What is the thing explaining stuff? What are they testing? Yep, they are testing a new dietary supplement. Good. What is the response that they will be measuring so you know if it works or not? Good. So reduction of cholesterol levels. Okay, now, they give us some information of something that could be a confounding variable. What is it that could also affect cholesterol levels? No. Smoking. They're saying, hey, watch out. We're afraid that smoking can affect it. So what happens if just by randomness you ended up with a bunch of smokers in one group and not a bunch of smokers in the other? Then you couldn't tell if it was smokers because they're smoking or not that it made them do better. So we need to control. The smoking. And how are we going to control it? We are going to block to control. Now, people, you do not always have to block. You can just pure randomly assign to the treatment groups if there's nothing that you need to control. But they specifically indicated, hey, watch out, we have a problem with smoking, so you need to control it. Therefore, your brain says, ding, 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 I need to block. So what are we going to start with? $60 middle-aged men. Okay, let's control them by making 2 homogeneous groups. And what do you think those homogeneous groups are? Perfect. Smokers and non-smokers. Because I do not want to compare those those kinds of people together, because I think smoking can affect cholesterol levels. Now, quick question. Should I block them by their hair color? Why not? There's no reason, because you know what? Hair color doesn't affect their cholesterol level. You would only need to block if it's something that affects what you're measuring. Okay? All right. Now, remember, we need to write how and why. So, block by smoking. Why? I see you have a trait there. That may affect the way subjects respond. So it may affect, and then don't just say the way subjects respond. That's too generic. You have to, good. That may affect cholesterol level. I see you have a trait there. That may affect cholesterol level. Okay? All right. Now, what am I going to do within each block? Good. Each block is going to have its own what going on? Experiment. Yep. So let's go do a smoker's experiment. Smoker's experiment. So what do we do first? We randomly assign. Now, do we know that there were 30 smokers? No, we don't know how many were smokers. So we're going to have half of the smokers go to the supplement that we're doing. We're going to have half of the smokers. What do you think they get? Okay, get nothing. Now, let's talk about if a placebo is necessary. Should I give them a fake supplement in their mouth so that they think, ooh, I might be getting the real medicine? Okay, you want to do that if there's a psychological effect. Is cholesterol a psychological effect? No. So you mean them knowing that they're taking something special isn't going to affect their cholesterol? Then you don't need to give them a placebo. If they were measuring pain, then yes. If it's something psychological, then make their a placebo. But if it's just a straight up measurement like cholesterol, no need. All right, what do we write for this randomly assigned? Okay. Put all smokers in a bag. Then what? Shake well. And pull out half for supplement and half for nothing. Period. Alright, I think that's the worst is over now. Those are always the two annoying parts. Okay, after we give them their supplement or their nothing, then what do? What am I going to measure? Aha! Measure cholesterol level reduction. Okay, ditto. Yep. And now what? Compare. What kind of numbers will this be? Proportion or an average? These are number values. Your cholesterol is a number. So compare the average cholesterol reduction between the two groups. Okay. What you going to do in the non-smokers? I'm not. I'm going to repeat the above experiment in this block. Right? Who's going to write that over? Repeat above experiment in this block. Period. Done. Absolutely, yes. The part I dittoed and the part where I say repeat the above experiment in this block, absolutely. Okay, so that looks like it has everything. That's like a perfectly done one. So, what part is new from what you have done before? Yes. Everything from randomly assigned out was same that you've always done. Completely randomized was from the random assignment out. All that's different is this little front section. Otherwise, you've already done a lot of those. Okay? I tell you what, I think I want to have you do one of these on your own. And so, let me see which one I want you to do. Let's go ahead and do number 4, but I'm going to kind of talk you through. Let's talk through the way we might consider if we need to block or not. Okay? So here we go. Number 4, and then you're going to do it completely on your own, and I'm going to walk around and check and see if you have everything. So here we go. An educational psychologist wants to test 2 different memorization methods to compare the effectiveness to increase memorization skills. There are 120 subjects available ranging in age from 18 to 71. The psychologist is concerned that differences in memorization capacity due to age will mask or confound the difference in the 2 methods. So what will the design look like? So first, what is the explanatory variable that we're testing here? Okay, that's what we're measuring if it but what is the thing actually doing, perhaps doing the increasing of the memorization skills? Perfect, yes. Memorization method. So memory method. And there's memory method 1 and 2. Um, you don't have to, but I'm always doing it because I just think it's a good way to start. What response are we measuring? Yeah. Now, people, let me tell you something. More often than not, the exact thing that is getting measured should be written up there word for word. So that's a skill you should learn, is how to go back up there and sweep through that and find increasing, what you're going to be doing. Okay, so here, the response we're measuring is the increase in memory skills. All right. Now, they're afraid that the age is going to confound, and we got a wide range of age. So do you want to control that somehow? How do you want to control age? Good. We want to control age, so let's block by age. How do you want to do that? I don't care. Make it up. Okay, let's set some 18 to what? 18 to 40, okay? And 41 to 71. Okay, perfect. So there you go. And so I will block by age. I see you have a trait there that may affect the subject's memory skills. So how are you going to block? How are you going to block? By age. Why are you going to do that? Because age can affect memory skills. Yes. How are you going to block? Age. Why? Because age can affect memory skills. So that's your how and your why. So I'm going to walk around and watch you do your nice little drawing here, and we'll see how you do.